Welcome to the module on link analysis. In this module, we are going to discuss the entities that have got associations among themselves. In particular, we will investigate the importance of a node by the type of associations that it has got. There are two types of approaches being used to investigate such relationships among nodes. They are either centrality-based approaches or prestige-based approaches. We will also discuss PageRank algorithm in detail. That is a particular prestige-based approach and was the main reason behind the popularity of Google in its early days. It was introduced by Larry Page in 1998. Link analysis refers to a collection of techniques that can be applied to data having relationships among themselves. So we have got entities or instances that have got some sort of associations among themselves. In case where these associations among the data are not present, then machine learning approaches are being used. Either if it's a case of supervised learning or unsupervised learning, we have got a set of instances that are represented by a number of features. And these entities are considered to be in isolation, that is not having any relationships with each other. So using any machine learning technique, that is classification or clustering, these instances are evaluated in isolation for training a model. But if there are such relationships in the data represented by edges, then link analysis techniques comes into play. Link analysis is not something completely new, and it has been around for many years. In the time before computers, it was carried out manually to understand a given situation. For example, if the law enforcement agencies have to investigate a crime, they would create a network where the entities would represent the people, weapons, and different crime scenes, and then they would try to identify and explore the relationships between these entities, and that would help to understand the bigger picture and get to the actual culprit. Network analysis can also identify the holes, that is the missing bits or the missing pieces of information, which if known would help to identify the scene further. So similar approaches are being used to come up with algorithms that would investigate the entities in relationships to each other for any given problem. Now, if we consider the early days of the World Wide Web, search engines were playing an important role in connecting people to the resources that they were looking for. These search engines would rank the resources, that is web pages, against a given query. In order to do so, they would use a similarity-based algorithm like cosine similarity or TF-IDF so that people can get relevant content to their queries. Based on this similarity, the pages would be arranged in decreasing order of their similarity against a given query. Now, this was a very simplistic approach, and content writers started to exploit this mechanism. And they would create content where certain popular keywords would appear frequently without the content making any sense. Now, this was very hard to identify for the algorithms. Even today, the computers are not completely capable of comprehending any given text. So in order to counter this, different approaches were being explored. Few years down the line, in 1996, it became clear that content-based similarity is not going to be sufficient. Therefore, in those days, other types of approaches were also investigated. In particular, classification-based techniques were used that would group pages against different query labels. But now the problem is that it has got millions of pages against the given keywords. But in general, what we want is only 30 to 40 pages, and that also in a rank so that they can be arranged in decreasing order of their rank. So in order to address the problem of spammed content, the web pages or the resources were represented as entities and were linked based on the hyperlinks that they have among themselves. Now, this network structure is going to help in highlighting the importance of a particular node based on its associations in the network. And this structural importance, along with the keyword-based similarity, is going to be more helpful in identifying relevant content. Now, in order to identify the importance of this node, we can consider these edges as a token of trust from these nodes that they have in this particular node. So together they are going to help in evaluating the importance of this node. We can consider these edges as a positive vote that these nodes are having for this given node. So if we label them as A, B, C, and D, A, B, and C are supporting D, and that is going to help to identify the importance of D. Now this is also not something completely new, as in older days people used to talk to each other to recommend various professionals in a given field. This is called the mouth of word approach. This approach is still very active in promoting business and is termed as viral marketing. The reason why it always works even in today's world is that people trust the recommendations of their friends and families, that is, whom they personally know, in comparison to the ones that they do not know. Now, if we consider the World Wide Web as a virtual society where the pages are people, and if they are having a positive word about someone, that is represented as an edge. If more people are talking positive about an entity, then that entity is going to be considered as an important entity or a trustworthy entity. It also considers the importance of the node that is given the vote. If this node A itself is important, then if it is recommending or giving a positive vote about B, then that is going to help B a lot more as compared to this node C that may be relatively less important. In the same way, B is going to contribute towards calculating the importance of A and C. There are two types of link analysis approaches that would help us to investigate the importance of nodes in detail. They are centrality-based approaches and prestige-based approaches. In the coming lectures, we are going to investigate these approaches in more detail. So thank you for watching and see you in the next lecture.